This video is on energy. Again, another topic for GCSE, a big topic. Very few key things to remember. So let's just quickly go through it and get those top marks. So now, the first thing that we need to remember for our GCSE exam is how many types of energy stores are there. So the names are on the screen. I'm going to just quickly explain you what these means so that you can get the top marks for that. So let's just get started. So the kinetic energy is the energy which any moving object has. So a moving car, moving you, moving fan, anything that moves has kinetic energy. Anything that is hot has thermal energy. Okay, this is because of the heat. Chemical is because of the chemical reactions happening. The food has chemical energy. Chemical energy does not mean it has to be in a chemical. Okay, so even food would have chemical energy. Gravitational energy is because of the height. Say if somebody is on 10th floor, it will have more gravitational potential energy as compared to the person who is on 5th floor. Elastic potential energy because of the change in shape or size. Say if this is the size of the spring and if I stretch it, I've changed the size of this. So shape and size is responsible for elastic energy. So example, okay, I'm going to give you a very gory example. If somebody breaks their hand or leg, they're changing the elastic potential energy of their body. Okay, all right, that was a bad example. Nuclear energy is because it's inside the nucleus of every atom. So it is inside the nucleus. It is because of attraction and repulsion, complicated physics. You don't need to know that, just it is inside the nucleus of an atom. Electrostatic energy is because of the charges, separation of the charges. Magnetic, it is because of the magnetic poles. Okay, now the key things that we need to remember in the exam, whenever the question asks you what kind of energy changes are happening, so you always say this energy store, whatever energy store, is decreasing, because of which some other energy store is increasing. Okay, now this is a template. Let's just try and fill it up. When you switch on the kettle, which energy store is decreasing? The chemical energy store of the power stations. And the power station, somebody is creating electricity, isn't it? So the chemical energy store of the of the power station decreases, and the thermal energy store of the kettle increases. All right, another one. My car speeds up. Which energy store? Chemical energy store of the fuel, it decreases. So chemical energy store decreases, and kinetic energy stores of the car increases. Now, how these energies are transferred, how the chemical energy store of the fuel has converted into the kinetic energy store of the car is via mechanically, because I'm applying force on the accelerator. Sometimes, now how does the power station energy is decreasing and the kettle is getting its thermal energy, is because of electrically, you're switching it on. Sometimes you are burning a fuel and you heat something, let's say when you're doing a barbecue. At that time, how does the chemical energy store of the food increases? Is by heating. Then by radiation. How do we get heat from the sun? We so want those summers to be in now. So in the summers, we like the heat from the sun. How do we get the energy from the sun? Is by radiation. So different energy stores are interchange these Energy stores are changed from one to another via four pathways. So those pathways are these. Now, conservation of energy. Conservation just means uh, that energy is just transferred between the stores. Okay, it is never created nor destroyed. The total energy is always conserved. It is not lost forever. It is lost in some form. For example, if I'm driving on the road, the tires of my car get hot. So my fuel energy, my chemical energy is a little bit lost in that thermal energy, but it's still changed into one form or the other. The energy itself is never lost. Okay, let's just do one question. A student drops a ball of mass 0.5 kg from a height of 2 meters. Say, okay. So now it is at a height of 2 meters. What energy does it have? It has mgh. Okay. Assume there is no resistance. So now what we are assuming that there are no losses here. State the law of conservation of energy. Energy is transferred, is not lost. Okay, so that is the law of conservation of energy. Is transferred between stores. Calculate the gravitational potential energy. So we have the formula here. You have the formula on equation sheet also. So I'm just going to use mass 0.5 times G is 9.8 times 2 is the height. So 0.5 times 2 is 1. So 9.8 joules. Every energy is always measured in joules. Kinetic energy just before it hits the ground. So when you drop it from a height and it hits the ground, so the ball is here, what energy it has here is 9.8 joules. Now this energy is in the form of gravitational potential energy. When the ball reaches the ground, just before it touches the ground, the same energy is not lost. It is now converted into kinetic energy. So it will have the same kinetic energy just before it hits the ground. So 9.8 joules. What happens to the energy if air resistance is not ignored? So if there is air resistance, out of this 9.8 joules, some energy would go to the air resistance. So kinetic energy would be less than 9.8. That's the thing. Why? Because a part of energy would be lost as thermal energy. This is what air resistance would do. Air resistance would rub against the body and would reduce its kinetic energy, and the body would heat up. So it would be lost as thermal energy. Say, if there are losses, we are not using all of the energy available to us, that means the efficiency is less. So efficiency is how much energy you're using and how much is available. Say, writing efficiency is then how much you can use. So output is the one which you're using and how much you're providing input times 100. So that's it. So for example, if I am doing a barbecue in my garden, which I do not have a barbecue machine, but if I am doing it and I end up burning a fuel which gives 1000 joules of chemical energy. Okay, so this is the input energy now. So whatever energy I'm giving, that is the input. Now, once this energy has gone into the food, now obviously the entire energy is not going into the food. If I keep my food on my barbecue, a lot of heat is going wasted into the surrounding. So only let's say I'm using 200 joules for cooking the food. Okay, so this one cooks food. So what is the efficiency then? What is the efficiency of my barbecue? So the efficiency will be 200 divided by 1000, and that would be 0.2. So sometimes if the question asks you to convert it into percentage, just times it by 100, 20% would be the answer. Now, energy resources. Where are we getting energy from? There are different kind of energy resources. Always use this comparison languages like reliable. I'm going to use that. I'm going to give you an example. Let's see. First, what is renewable? Something that can be renewed are the renewable energy resources. For example, solar energy, wind energy. Solar energy can be renewed, can be reused. Wind energy, hydro is the water energy, tidal is the energy of the tidal waves in sea, geothermal is the energy inside the earth. Sometimes, near the volcanic areas, the energy inside the earth is used to heat up water, and then that energy is used to create electricity. Biomass is we grow plants and then we use those plants to burn and create electricity. Waves, again, the waves of the sea are used to create electricity. So these are all renewable energy resources. The advantages, they're not going to finish. They do not have any carbon dioxide emissions, but they're not reliable. The non-renewable resources which are going to finish, they are finite. Finite means they're going to finish one day. So these finite energy resources like coal, oil, gas, nuclear are reliable. Okay, so if I want to get instant electricity today, I can burn coal, but I don't know whether there will be sun today, whether there will be wind to create energy from wind, whether there will be tides in the sea. So these renewable are all non-reliable, except the biomass. Biomass is reliable. Now, why we don't want to use non-renewable energy resources? First, they're finite, they're going to finish. Why do we want to use them? Is because they are reliable. Cost, they're not as expensive as creating a wind power plant. They are most disadvantage. The biggest disadvantage of the non-renewable resources is for the environment. Okay, so what kind of disadvantage do we have for the environment is that they produce carbon dioxide, which is a greenhouse gas. Now, why greenhouse gas is, from if you're doing geography, that it produces heating effect, which is a cause of global warming. So use the word, don't say it is harmful. Why is it harmful? Why the non-renewable resources, why burning coal is harmful is because it produces gases like carbon dioxide, sulfur dioxide, which are greenhouse gases and produces global warming. Okay. Now, the next thing that we need to know, high voltage, low current explanation. Now, what is a power station? A power station is the one that creates electricity. So, the power station creates electricity. Step-up transformer increases the voltage. So, this one increases voltage or potential difference. I'm writing PD, potential difference, and decreases current. Why do we want to decrease current? Because when we decrease the current, we decrease thermal losses. Okay, and everybody wants to decrease losses so that they can have high efficiency. Then we have transmission lines that transfers this the voltage created in the power station to the homes. And then the step down transformer, it decreases potential difference. Why we want to decrease the potential difference is to make it safe for the homes. A large potential difference is not safe for the home. Okay, I'm just going to write it safe. Okay, so just sometimes the questions are as simple as that. Name what is a national grid made up of. Name 3 elements of a national grid. So all of these are the elements: step up transformer, transmission lines, pylons. Why do we need step up transformer? Increases potential difference, decreases current, decreases thermal losses. Why do we need step down transformer? These are all the questions of your exams. Again, the equations are there all in the equation sheet. This one is for the triple if you're doing triple. And yes, that's it. You need to know the meaning of every single term, and you should also be able to rearrange them. Go ahead, pause and try to answer all of them. Check your answers if you have done that. And now the specific heat capacity. Now, specific heat capacity, sometimes exam boards would ask you define what is specific heat capacity. So you need to write both of these important words. Energy needed to raise the temperature of 1 kg of a substance by 1 degree Celsius. To raise temperature of 1 kg by 1 degree Celsius. Equation you have in your equation sheet, mass, C is specific heat capacity. This triangle, it means change. So this means temperature change. Okay. Now remember, whenever a body is being heated up, how much energy it would take, it would depend on its specific heat capacity. So water has a specific heat capacity of, I'm just going to write here. So specific heat capacity of water is 4200 joules per kg per degree Celsius. What that means is 1 kg of water for 1 degree rise of temperature requires 4200 joules. That is the meaning of specific heat capacity. If you are taking a bath in the morning and you're using 10 kg of water and you're heating it up only by 1 degree, that means your house is using 42,000 joules of energy. And if you're raising it by 10 degrees Celsius, 10 kg for 10 degrees Celsius, your house is using 420,000 joules of energy only for your bath, an expensive bath. Okay, let's just say if I'm heating 2 kg of water by 30 degrees Celsius, how much energy do I need? So I'm just writing. This is how you should do when you're writing in your exams. Write the formula from the equation sheet and then just plug in the values. 2, 4200, and then 30. I've also made another video on energy, which is, and electricity, which is only exam questions. So that would help you to understand the application of some of these concepts. Okay, so this is 0, 0, another 0, sorry, another 0, 3 to the 6, 3 4 is 12 times 2. So this one is 0, 0, 0, 12, 2 is 4, 5, and 2. Just so that's it. So see, can you see how much energy just by 2 kg? So that is because water has a very high specific heat capacity. Now, thermal insulation, another topic. How can we reduce heat losses in our house? Okay, so this topic is related to reduce. Remember, we want to reduce heat losses because that increases the efficiency. Now, why do we want to reduce heat losses? If you have less heat losses, you'll be wasting less energy. If you're wasting less energy, what would happen? Less electricity bill. so you'll be saving up some money. Okay, and also you will be helping the environment, because we remember we create electricity by burning renewable or non-renewable resources, so they are affecting environment. All right, so how can we do the thermal insulation? By using loft insulation, cavity wall, double glazing, drought proofing, tank. Okay, tank jacket. So tank jacket is a jacket which some people put around the boilers. Even I have put that in my home. So this is your boiler. So it will have a jacket around it. So it will reduce the heat loss through convection, conduction, and also radiation. Curtains would stop the heat going out by different processes. I'm just going to explain you these. Conduction. So conduction happens whenever there is a heat flow through solid. For example, this is the wall of your house. Okay, let's just make it a bigger wall. So here is using the heater. Okay, the temperature here is, you have maintained nice 20 degrees Celsius, and outside it is freezing cold and it is 2 degrees Celsius. So what's going to happen? The heat is going to flow from higher to lower temperature through this wall, so that is conduction. When the heat flows through a solid, that is conduction. Now, the outside of the wall, so the outside of the wall is as 2 degrees Celsius. Now, if the wind starts blowing, so this wind would take away the heat quickly. So this flow of heat, because of the flow of air, is increasing the heat loss. So that is convection. And so conduction, solid, convection, whenever there is some air somewhere or some liquid that is flowing and taking away the heat, that is convection. Now, radiation. So everything, let's say the wall, you have made the wall a cavity wall. So what do? Is you do a cavity inside the wall. So again, you are 20 degrees Celsius here and you are 2 degrees Celsius outside. So the heat, so this cavity here will have air in between. So this air is an insulator. It will not let this heat flow out quickly. So you've done that. Okay, so you reduce the conduction, you can't reduce the convection because you still can't reduce the speed of the wind, but you've reduced the conduction. Now, the heat source, the heat from your body, from your house. So I'm going to just make a house here. So the heat from the house, okay, that's a very horrible house. So the heat from your house, the house, just like sun, it emits heat in the form of radiation. So this emission of rays is radiation. So heat is lost via 3 methods: conduction, convection, and radiation. And we try to reduce heat losses by these methods. Now, work done whenever there is an object moving. So let's say you're applying a force, you're trying to move the bed. Are you going to lose some energy? Are you going to get tired if your mom asks you to move the bed by some distance? So where is your energy going? Your energy is going in doing this work. And we calculate work by this formula, force times distance. Again, there in your equation sheet. So, but what we need to know from the energy topic is this work is equal to your energy loss. Okay, sometimes the work can also increase the energy. Okay, like for example, if somebody is using a motor to pull up the mountain, so whatever the force motor is applying, and it is moving up a distance d, because it's going up a height, which energy of this body has increased? Gravitational potential energy. So what you need to know here is that work is equal to energy. So that's the only thing you need to know for exam, that work is equal to energy, and energy is measured in joules, work is also measured in joules. You will have some questions which will want you to use this equation. So just plug in the value of force and distance and get work. Remember, work comes from energy or work goes into energy. And then work is nothing but energy, and power is also energy over time. So we can write power as work over time. Okay, this one is for triple. So force times velocity. Okay, now always when you get the exam data question, when it has some numbers, this is how you should do. I've written this, so let's just do number 1. What is it asking us? Underline the data. Okay, let me just use different color. Say 132 joules is energy transferred. Temperature change is 20 degrees Celsius. So that is temperature change. Mass is 0.5 kg. Calculate the specific heat capacity. So I'm going to write the equation mc delta T, rearrange E divided by m times delta T is specific heat capacity. So if they have nothing in between two things, that is multiplication. Now let's put the values. So this is 132 divided by 0.015 times 20. That gives you the specific heat capacity, and just using calculator, so that comes out to be 440. Now writing unit is important, that we write it properly. The unit for specific heat capacity is 440 joules. See, 132 was in joules, so joules divided by what was 0.015 in kg, so kg, and what was in 20 in degrees Celsius. That's it. Although you might not need to this, most of the time your exam questions would have the unit written, but there's no harm in understanding the method. Okay, now, so well done. This is all you need to know for energy topic. Go ahead, revise it again, and do well in your exams. Thank you so much.